Every time we've used a new spacecraft to look at a planetary body, we've always learned something we didn't know before. Our experiment, called the Moon Mineralogy Mapper, or MCube for short, was sent to orbit the moon for 10 months, which provided ample data for us to analyze about the surface characteristics. Much to our surprise, what we found on the moon is not puddles or rivers, or certainly not oceans, but just a little bit of water on the surface rocks and soils. And what makes this important is that although it's a small amount, it covers a large area.
What we found was that rocks that lie on the surface of the moon had water. And this rock came from the interior of the moon, that tell us that the interior of the moon had water. That was contradictory to the ideas that the moon was bone dry. But now we get all these, and all the ideas that are coming out from this is the most interesting. How much water, where that water come from, is what we see on the surface the same as what it comes from the inside? All those things are really, really interesting. As a scientist, you always want to be at the tip of what's going on, at the best discovery, at the newest thing, the things that will revolutionize everything.
There were clues there might be water ice on the poles. So this mission, L-Cross mission, was intended to actually slam into the poles of the moon and actually dig up stuff that might be buried below. We get to do something that you do as a kid. You throw a rock in a pond. You do a cannonball off a high dive. You create this big splash. That's the same thing we're doing. Instead of the splash of the water from the pool, we're hoping we're going to get a little bit of the ice that came from below the surface. We dug into the moon, so right now we're digging into the data.
In Apollo, we knew a lot about 6 local areas that the Apollo astronauts analyzed. What we didn't know was what was going on in the intervening terrain, which was, of course, most of the surface of the moon. LRO, the Lunar Reconnaissance Orbiter, is the U.S. spacecraft that is now in orbit around the moon. It has a bunch of different instruments to study different aspects of the moon. I'm working on LOLA. It's a lunar orbiting laser altimeter, and we're seeing details now, heights of rocks, depths of canyons, dimensions of craters that are just completely revolutionizing our thinking about how geological processes work on the moon.
The future of NASA exploration of the moon involves sending humans back there. And in order to do that, and in order to do it in a safe and effective way, you need to fully characterize what the lunar surface and the lunar environment is all about. And so Diviner is one instrument on the Lunar Reconnaissance Orbiter spacecraft that's providing us with the temperature information for the moon. And because we can know temperature, we can understand where is it safe to build future lunar bases. We can also look at how the lunar surface heats up and cools off to understand how big and small rocks are to identify safe landing sites in the future. And so all of this data together is designed to help support the future human exploration of the moon.
As a lunar scientist, I've studied the moon with telescopes and instruments on telescopes. I've studied lunar samples, and from that you have information, and you think you understand not only what the data are telling you, but what the most important questions are. But what's so thrilling with this new information is you learn there are things you never even thought of before that are important and are surprises that makes you realize you're thinking in a box. And with new information, you have to think outside the box.
If you think about the evolution from my early years of looking at the moon 35 or 40 years ago to what we see now, it's as if you've gone from black and white television to full Technicolor color television with depth and stereo. It's just unbelievable. In the old days, we had black and white photographs, and these were very informative, but it's nothing compared to what you can see now with this incredible dynamic moving color image of the moon and its geology. It's just revolutionary.